Yeah?
Okay, so what we've got to be able to do, a couple of things. Determine the inverse function, so you've got to be able to find it. You've got to be able to state the domain and range of the inverse function. So you should already be able to state the domain and range of the original function. And then we want to be able to, there's a bit about recognizing the transformation of the graph of the function and what its inverse function graph looks like. Okay, so you need to be able to sketch that kind of thing. Right? So, if I ask you what you think an inverse function is, what would you tell me? What would you guess at, hypothesize that, whatever word you want to use? What do you think, Michelle?
It's like the opposite of the function that we have.
Okay, so if it's the opposite of the function, I told you there were two things that we do with functions last time. What were those two things? Yeah, solve was one of them, but not find. I said substitute. Substitute and solve. Okay, so if the inverse function is the opposite, what is it related to substitute and solve?
It's maybe the other way around.
Sorry, probably badly worded question. If you substitute in, remember which direction that goes, and you solve, you go which direction you go. If you are using an inverse function, so let's say if you are substituting into an inverse function, that is the same as doing what with the original function? Solving. Okay, so this is the first thing. So if we go from x as an input and we put it into f of x, we get our output. Right? If I start with my output and do it this way round, okay, so this is solving for x. Right? But you can't put the answer into the function to solve for x. That's not how we do it. So actually, this notation isn't quite right because we don't put a number into f of x. We have to do something with it. And you guys all know you have to do a rearrangement or however you want to do it. You leave x on its own, that kind of thing. In reality, what you are doing is you are, whatever the answer was, becomes our x, and we are going to put that into the inverse function, and notation for inverse function is f to the minus 1. And that will give you your solution to the function. Okay? So the happy thing here is, if you've ever solved an equation, you have already found the inverse function. You've been doing it for years. Okay. You've maybe just got to write it in a different way. Something else that you must, like, to go along in the same vein, if I said to you f of 3 equals something, what does that mean I'm doing? What does that mean using? Michelle?
You're replacing 3 with 3.
Is it substituting or solving?
Substitute.
So substituting 3 for x, and I get an answer. So f to the minus 1 of something equals something. So think of the inverse. This tests your understanding of what I've been talking about. So what would go in this? So let's do k for an answer. I'm not going to use y because it's not during the graph, but if f of 3, I substitute it into the function, I get an answer. How does it work here?
You put k.
Okay, so I do f to the minus 1 of k equals 3. Okay, so that's quite an important thing for us. Therefore, f of, let's say f of x equals 7. Alright, so how would you write that but with inverse notation?
F to the minus of 7 equals
X.
Alright, so making sense. So, like I've said, you've all done this before. You've all rearranged to solve for x. It's just a matter now of making sure that you can write it as an actual function. So, if we take some simple cases, so we'll write this down. Writing the inverse function. So, for instance, if f of x equals 3x minus 1, what do you think f of minus 1, f to minus 1 over x equals? What's the inverse function? Not quite. So just in case you don't get where that comes from, this is a method for you. So what we do is we write y equals 3x minus 1 using the y and x notation. What we then do is make x the subject. Sorry. All right. Make x the subject. Do you know what I mean by make x the subject? What does that mean, Simon?
Make y dx.
Make y dx. Yeah? Okay, so I'm basically wanting it as x equals. I guess that's what you're trying to get to. So, how do we do that? Now, just one thing I will remind you, I think I said to you, I'm sure I have, don't use the word move. Michelle?
+1 from both sides.
So a +1 to both sides, because I'm going to write it out in full, you don't have to do this, but if I add 1 to both sides, it becomes this. And then that has cancelled this side out. And then,
Divide y plus 1 by 3.
well, we
And then
divide
divide
both
both
sides
sides
by 3. So we're doing the same thing to both sides, keeps it the same. So then the 3 divided by 3 makes 1, so we have y plus 1 over 3 equals x. Now, the inverse function, basically, once you've made x the subject, you swap the x and the y. So we actually write x plus 1 over 3 equals y, and then the inverse function is x plus 1 over 3. So that is the inverse function. And just to check that we've got, understand everything we need to, so if we do a check, f of 3 equals 3 times 3 minus 1, which equals what? What's it equal? 8. And if I do f to the minus 1 of 8 should equal what? 3. Should equal 3. So let's just check. 8 plus 1 over 3 is 9 over 3, which equals 3. So we're right. Yeah. So now, all you've got to do is be able to apply this to a range of different functions. Okay, so I'm going to ask you, please, to turn to page 20, exercise 1H, and I'm going to ask you to do question 2 and 3. Okay? So, say, page 20, exercise 1H, questions 2 and 3. Okay? I'll let you get on. So, what I want you to do, looking at those functions that you've just done, and you found the inverse function, listen, okay, put pens down. This is the next important bit. I want you, using your calculator, to graph f of x and f minus 1 of x on the same axis. Okay, I want you to graph it. Do it for a few of them. Alright, so not all of them on the same thing, just put f of x and its inverse on the same axis. And I want you to tell me what you notice. So do it for all the ones that you've done. Alright, and I want you to tell me what you notice. Okay? Everyone clear? Now one thing, with your calculator, have you got your calculators in front of you? Alright? When you are in the graphing screen, you will see y1 equals, y2 equals, y3 equals, and so on, yeah? Everyone know what I'm talking about? Alright, just a little tip. What I need you to do is keep putting all the functions in. So put the first two in y1 and y2. Look at what it does. Don't delete them. Put the next ones in y3 and y4. There is a reason I want to do this. But what you do is when you have put a function in, what happens is the equals will be highlighted. Alright? That switches the graph on or off. So if it's highlighted, the graph will show on the screen. If you go over the equals and press enter, it switches it off. So on or off. So what you can do, for instance, is if you have y equals 2x plus 3 in this one, and then you have x minus 3 in brackets, divide by 2 is how I would write it, and unless you've got the updated one where you can do it as a fraction, I would have both of those equals highlighted to see what happens. I would then put the next ones in. So x cubed minus 1, the next one will be x plus 1 cube rooted. And what I want you to do then is switch off those two, but leave them there, and then switch these two on. So it will look like this next time. It's going to rub out the equals, isn't it? Right, so you switch those ones off. That way, after you've done your little bit of investigation, I can tell you one thing, and you'll see whether we spot the right thing. And then we can go back through all the ones that you've done, and you can see whether it works. The next thing. Everyone understands, yeah? To get into the habit of switching it off rather than deleting the function. Okay, right, I'll let you do your bit of investigation. So I asked you to compare function with inverse graphically, because part of your objective was to understand the link between the two. So hopefully, if, for instance, if we put in, give me one of your functions, f of x equals, well, what about 2x plus 3? I'll do a simple one. 2x plus 3 looks like that, and if the inverse is, what's the inverse to that? Y equals, so better do it in brackets, x minus 3 all over 2. Okay? So, now obviously my aspect ratio, it's not squares. I think I can probably do that actually. Okay, look. Now, it is a reflection, right? So if I were to draw the line y equals x, it goes straight through the middle of it. Alright? So the function and its inverse are related by the fact that one is a reflection of the other. So, for instance, let's try a different one. What about your cube root one? Have you got a cube root function? So, what is it? Y equals, what does it start? X cubed. So, x cubed minus 3. Looks like that. Okay. Now, for instance, if we know that it is a reflection in y equals x, a question might be, well, here's the graph. Sketch the graph of the inverse function. So you just have to roughly put it in the right place. Now, if I were to look at that, would you be able to sketch the reflection of it? Well, I'm going to assume you'll all go, yeah, we can do that. Bit of care and attention. So, for instance, we pick the important point. So, it crosses the x-axis there. So, where will that point be for the inverse?
Y-axis is the same.
So, y-axis is the same. Now, here's the thing. This is why the reflection is in y equals x. Because this x value of 1 point whatever will give me a y value of what? So an x value of 1 point whatever will give me a y value of 0. Thank you. Someone showed a bit of understanding. If it's on the x-axis, the y value is 0. Therefore, to find the inverse, basically what did we do? So x goes into the function, becomes y. What goes into the inverse function? Y, and you get x. But what do we call y when we put it into the x function? Oh, so the inverse function. What do we call it? Do we stick y in or do we stick x in? So what we're saying is what was x becomes y, and what was y becomes rx for the inverse function. So it makes sense that if what you're doing is swapping the x and the y, you know when you did your rearrangement and you make x the subject, so you have y plus 3 over 2 equals x. What was the next phase? To swap x and y again, wasn't it? So you just swap them, and by doing that you are reflecting in y equals x. So whatever is here, we take the x and make it y, so it will go there. This is the other important point. What is y becomes x. So then we would say it's going to be a line like this. Okay, so if we check, for instance, that we've got our inverse function correct, for instance, if I were to put in what some of you have been doing, which is, I don't know whether I can do cube root. I don't think I can actually. I'm going to do cube root in a different way. I'm going to do x to the power of, no, let's do it like this. Okay, guys, new computers and all that. When you want, there we go. And then, so x to the power of, I'm going to choose a third. That's the same as cube root. For those of you who remember your rules of indices, cube root is the same as the power to a third. And then I'll do plus 3. Okay. So that's what I've done. Is my inverse function correct? So just to show you on the other board, I've started with y equals x cubed minus 3, and then I've done the inverse function as y equals the cube root of x plus 3, which is what some people do, right? Because they've done the inverse of the cube, so on, right? And they've done the inverse of the minus 3 is plus 3. That's what I've got if I graph it. Is my inverse function correct? No, because it's not the right thing. So what would the correct inverse function be of x cubed minus 3? So y equals x plus 3,
Cube
all cube rooted. Okay. So if I were to adjust my function, alright, so this is how you can check. So it should be x plus 3 cube rooted, like that, yeah? Happy? And now I do get the right thing. It's almost a what?
Almost a part.
Almost.
How
Almost.
do you make everything else disappear?
Oh, yes, I see it.
Okay. How do I make what?
How do you make, okay, so you got this shape, but how do you make the rest
And
disappear?
beautiful.
So you have to use different functions there.
I wonder if mathematicians use graphs to make women fall in love with them.
Right, anyway, so you get the idea.